Welcome to Cisco's 5G Cloud Native demonstration. Here we're basically showing you how the combination of our orchestration, automation, and end-to-end network 5G upgrade allows us to bring the capability to the packet core. And the packet core is where you bring your services and your customers together. And when we talk about services, it's not just about the capabilities on the gateway, it's the capabilities of the network. And the gateway today started from physical, it went to virtual, and we're actually implementing cups today. But this is not necessarily sufficient to meet the needs of a 5G network. We really need to go towards a microservices disaggregated gateway so that we can actually have the flexibility to anticipate any use cases that will come as we go into the 5G domain. 5G is going to ask us to have a lot more speed, a lot more capacity, and a lot more flexibility to add new services to the network. And when we do this, we actually have to deploy things a lot faster because the value of those services is going to go down, but the more we can deploy, the amount of revenue can actually go up. So to be able to deploy these much faster allows us to get to market sooner, get revenue sooner, or determine that we need to go back and essentially fail fast. We also need to do this at much lower OpEx. The problem that often happens with physical, even today's NFV-based implementations, is that the OpEx to actually run these is significantly higher than we need to actually generate revenue from these new services. So how can we actually run the network in a lot more cost-effective manner? But all of this really requires us to reduce the risk of adding these new services. And the idea of reducing the risk is that how can we actually implement a new feature on the gateway, on the network, without interrupting the existing services? This we can do through slicing. The idea of slicing is the ability to take your software and actually take it into small pieces and use those small pieces for different functionalities. So here at Cisco, we're launching our 5G Cloud Native Packet Core. So the core network is essentially based upon microservices, which uses the network service mesh, so that all of the functionalities are broken into microservices. These are containerized such that they can run independently from each other, they can be upgraded independently from each other, and they can scale independently from each other. Furthermore, by using the 5G service-based architecture, we can actually deploy these in a zero-touch manner, i.e. the amount of requirements from the staff to actually configure these is greatly reduced to zero. So from our cloud-native implementation, we also allow us to go run on bare metal, run in VMs, and also run in the public cloud. And we'll show you all three of these working today. So in today's demonstration, we actually have today a 5G cloud-native access network and an internet slice already running. And as we move towards software, we actually need to consider that the user plane is also based upon software. So Cisco's initiative on VPP, i.e. the ability to run the user plane using vector packet processing, has allowed us to go from a single server running at, here you can see 400 or more gigabits per second. This is one UCS M5 server able to do this kind of speeds. This is a real traffic flow model. We can see here we have 8 UPF network functions on one server scaling to that degree of capacity. This allows us to put not just a big one, but also a very small UPF at the edge and run it at very efficient resource capacity. Now, what often happens is that if you have such a large network, can you actually risk putting in new services on this existing network? And especially as we look at where GSMA has identified the new use cases are coming from, which is essentially enterprise, would an enterprise want to mix their services with this level of usage, with this level of existing functionality, when they want the flexibility to add their new services, such as we've seen elsewhere in our demonstrations with the Unified Domain Center, or existing network transport networks using our SD-WAN technologies. So to do that, we actually create a slice to create a new network. So here we can see here in our data center, I've already deployed here in Barcelona 2 slices, one for access and one for the internet. But what I'm going to do here is actually create a new slice for my enterprise. And I can do this very simply. I just select the network functions I need, so I select the PCF for policy, the session management function for sessions termination and management, and the UPF, as I explained, is our user plane running in VPP. And then now I need to give this a name, and I'm going to use it enterprise. And actually I'm also going to select a different cluster to deploy it on. The reason for doing that is that the SLA for a slice is not just the network functions that are defined by the standards, but also a data center that's segregated to meet the SLA of this customer. This could be, for example, deploying the database in 3 locations to get full geo redundancy, or even 5 locations to increase it to 6 nines availability. And now I click instantiate, and essentially the demo is done, because now the system will go off and actually do everything for us automatically. So if you return here, we can actually see the data center in cluster C has everything starting to be deployed. And what's actually happening behind the scenes is we're using this netconf tool, the GUI that we have here, which is available again from Cisco's CX services, to actually go and program our network services orchestrator, NSO, to actually pull in the netconf and YAML files to actually define the slice. And here we can see slices that we've deployed. There's 5 of them. We have obviously the access slice, which we can synchronize and it's available. We have the internet slice, which we can access and synchronize and it's available. And now we just launched the enterprise. And from NSO's perspective, it's pulled not just the software that's needed for this, how much needs to be deployed, as in how large these network functions need to be, but also, more importantly, the configuration. So actually putting the configuration automatically into the network functions based upon an automatically generated YAML file allows us to basically walk away and leave this to work. Now up here we can actually see that we'll find when we launch this, there'll be an enterprise KPI. So we're using our open source tools that come with our cloud native execution environment to actually capture all the KPIs that get populated into Prometheus. Here we're using Grafana, you use Kibana, so once actually a call comes up, we'll actually see the data populated here. But prior to that, we can actually see, again, using the open source tools that come with a cloud native implementation, so Cisco's Ultra Cloud Core, we can actually pull interesting information that allows the service provider's operational team to identify how well a call is actually working. So here we can scroll down, we can pull out the traces, and again, this tool, it's open source. It uses a piece of software that sits in the network function to actually identify the key sources. Furthermore, we actually have integrated the Dynamics application. So the ability to actually put third-party software inside the network function allows us to actually identify the traffic inside the software, inside the network function, and identify if there are any issues in the actual infrastructure. Here in this case, we have the session management function, we have a REST endpoint, and we have the actual service. We actually separated out both the service and the actual endpoints so that we can actually scale these independently. And furthermore, we've also separated out the state from the actual application to a database. And this allows us to move towards in-service upgrades, do canary upgrades, so we actually can put in new software whilst you're running in runtime. So the idea here is that not only do we actually reduce the risk because we can actually run the software on the actual deployment that's going to be there, but also we can do it during the day when the operational costs are also much lower. Now, going back to the monitoring tools, so if I go back to the data center, we can see how the enterprise is still coming up, and the new slice is actually being created here. All the functions are up and running, and this 100% means that NSO has actually deployed all the pods necessary to have the network function up and running. When I talk about pods, this is something we deployed on Google earlier, so in Google Cloud Manager, we can see all the network functions and microservices that are made up there. And this again, NSO polls this to actually identify what's available. So here we have the slices up, and we actually have a tool here to verify if the actual slice has been provisioned correctly, because we actually connect a call, and then we can actually identify the actual signaling that's happened on this slice. So again, we go back to our Grafana tool, and here you can see we started to populate the KPIs with the slice information for the enterprise slice, and all the different transactions that are taking place. And this allows the operational staff to, again, very, very quickly identify if the slice is working again. This can all be automated, and you can identify a notification when the actual slice is up and running. Again, this all happened in the space of just a couple of minutes. Now, going back just to reiterate where we are, we've performed this slice deployment in a very short space of time, which really, in a matter of just a few minutes, I've been able to do what typically took several hours, if not days, and in the old time we're using physical boxes, several months. Again, this user plane is very high performance. At a very small footprint, we can do a lot of traffic, or even just a single server, 400 gigabits of throughput. And our time to market means I just launched this new service in a matter of minutes, which means the enterprise who's basically saying, can I have my application now? They can actually see it running on real time. And lastly, I want to reiterate that we have a huge number of virtual deployments. More than 90 have been deployed so far. And on top of these, we have around about 300 million sessions that allow us to learn a lot about the difficulties and challenges and come up with software and automation tools that solve all of these. And again, for our optimization of throughput, we can have 400 gigabits on a single server. And finally, just want to show you that now that we have these enterprise slides up and working, just as easily as I started it, I can go off here and terminate it and take the resources back and put them back into the pool of resources so that I can start another service. So we can start quickly, we can fail fast, and go back to revenue as soon as possible.